Okay, so hello for all. Sorry for the delay for the presentation. So I'm Alaa Salma, a research associate at UniLasalle RAN. Today I want to speak about a part of biochar project that aim to study the impact of biochar integration in anaerobic digestion. And this project is financed by the Brittany region. So move to the next slide. This project will last for 18 months, and here we can see the outline of the presentation, starting with a brief introduction for anaerobic digestion process. So if we move to next slide, we can see that anaerobic digestion is a biological process that breaks down organic matter such as animal manure, agriculture waste, wastewater, and food waste in the absence of oxygen. It involves the activity of various microorganisms, primarily bacteria, that thrive in oxygen-deprived environment. So these microorganisms convert organic materials into biogas, and the produced biogas, primarily composed of methane, can be used as renewable energy source for electricity and heat generation, as well as vehicle fuel. Also can be injected in gas grid, and to a nutrient-rich residue known as digestate that is considered as a valuable resource in the form of organic fertilizer that can be stored depending on the time of fertilization needs. However, there is a concern associated with the disposal of or the application to land of this digestate, and the new recommendation and regulation goes to reduce its landfill. So by reintroducing digestate in the anaerobic digestion process, it can be further processed and treated, which may reduce potential environmental concern associated with its disposal or application to land. So moving to the next slide. Now we want to speak about the transformation of organic matter during the process. So we have decrease in the organic matter in the digestate. We have a preservation of nitrogen in the digestate, however, an increase in their mineral fraction. It is worth to note that the specific characteristic of digestate depend on the substrate used, which is the organic material subjected to anaerobic fermentation, and also the process applied. So different type of organic materials and varying fermentation condition can result in digestate with distinct nutrient content, pH level, and overall composition. So digestate often contain a variety of nutrients, including nitrogen and phosphorus, potassium. Also, it contains inhibitory substances such as volatile fatty acids and ammonia and hydrogen sulfide, which can accumulate when digestate is reused. And these substances can be detrimental to the anaerobic digestion process and require additional process control or treatment. And here comes the role of biochar, because according to the literature, biochar can act as support for microorganisms. It counteracts with the excessive production of volatile fatty acid, mitigate ammonia inhibition, absorbs the trace metal element, sequester the carbon dioxide in the digester, and remove hydrogen sulfide, as well as favorize the direct interspecies electron transfer. And if we see the figure here, there is an increase in the number of publications that speak about biochar and anaerobic digestion between from 2003 to 2022. So there is a definite interest in biochar and anaerobic digestion. Moving to next slide, so the addition of the incorporation of biochar in the anaerobic digestion could improve the production of methane, and for this reason, the purpose of the study was to explore the impact of biochar in the process, the anaerobic process, using digestate as substrate. So now we want to speak about the materials and methods section. Yeah, materials and methods. Yeah. So the substrate here is the digestate that is put it in the anaerobic bottle with or without biochar, with different concentration and different type. Also, we have tested some additive or trace element. After a few days, the quality parameters of digestate are tested, such as volatile fatty acid, complete alkalometric title, pH, dry matter, and the biomethane potential. Moving to next slide. Different type of biochar are tested, and in this table we can see this type and the characteristic of each biochar. That is differed by their source material, production method, surface area, density, ash content, and production temperature and residence time. After that, we want to speak about the apparatus used, which is the AMPTS system. AMPTS stands for Automated Methanization Potential Test. That used to detect the methane potential. So how it acts, we put the substrate in the bottle under agitation. So the organic matter are broken down, carbon dioxide and methane are produced. The carbon dioxide is absorbed by the sodium hydroxide, and the methane is analyzed or going to the detection unit. And now moving to the result and discussion section. First, we study the effect of biochar concentration on biomethane production of digestate, and we can see clearly that the addition of 1% digestate resulted in higher methane production level, albeit slightly higher when compared to their respective control. Also, the addition of 2% and 4% of biochar 1 have no positive impact on the methane production. So for this reason, we have choose 1% of biochar for our next experiment. The next slide, you can see the effect of different type of biochar on biomethane production of digestate. So the figure here shows the profile of accumulated biomethane volume, where the effect of different type of biochar were tested after 14 days. So we can see that biochar 1 was the most effective in enhancing biomethane production. At the end of the experiment, yielded about 22.8 normal milliliter methane per gram of dry matter, which correspond to a productivity of 1.62 per day. And this is likely due to the high porosity and the surface area of the spruce biochar, which provide more sites for the colonization of methanogenic bacteria that produce biomethane. Also, interestingly, biochar 2 showed a similar performance to biochar 1. However, as the experiment progressed, the biochar 2 outperformed the biochar 1 yield by 2.4%, indicating that the addition of biochar 2 that have a positive impact on the production of biomethane over a long term. On the other hand, biochar 3 showed the less performance in the biomethane production compared to raw digestate and to other biochar, and this could be attributed to the high ash content and the presence of the copper in biochar 3, which may have a negative impact on microbial activity in the process. Moving to next slide. Here we study the volatile fatty acid profile for each experiment. So we have decreased in volatile fatty acid at the end of the process, except for biochar 1. And this result is a little bit critical. We need to repeat this experiment because normally biochar decreased the concentration of volatile fatty acid in the process. And this could be happen through several mechanisms, such as the the absorption of these volatile fatty acids that reduce their concentration in the media. Also, if we look at the second figure, so we have the complete alkylometric title, and we can see an increase of the complete alkylometric title at the end of the anaerobic digestion for all states, which suggests a successful organic degradation of the matter in the digestate. And the table presents here the pH, the dry matter pH, the chemical oxygen demand, and the ratio of volatile fatty acid to complete alkylometric title. So we have a decrease in the pH, but still in the optimal range for the methane production. We have an increase in the chemical oxygen demand at the end of the process. And this is likely due to the incomplete degradation of the matter. And for the stability of the process, we look at the volatile fatty acid to complete alkylometric title. And we can see an increase in the ratio, which suggests a stability of the process. Moving to the next part of the result, we study the effect of biochar and trace element addition on biomethane production of digestate. So the figure here shows the profile of yield and the productivity of each experiment tested with or without biochar and trace element addition. So as trace element, we choose iron because it's considered as an essential trace element for the growth and activity of many anaerobic microorganisms involved in the process. So it acts as cofactor for some enzyme involved in the process, and its presence in trace amount can promote the growth and activity of these microorganisms. So we choose hematite and iron chloride in this study at low concentration. However, we haven't seen any positive impact on biomethane production yield or productivity, where biochar is added or no. However, when we use activated carbon powder, we have seen an increase in the methane production by 11.4%. So we can conclude finally that digestate can be reused in anaerobic digestion, and adding low ratio of biochar has a positive impact on biomethane production of digestate. And especially adding biochar 1 to digestate slightly enhanced the production of methane, and no positive impact on the production of methane when trace elements were added. Finally, we have some technical challenge. As each project, we have a limited time, difficulty to identify and engage in collaboration with the agricultural organization to recuperate the input material. We have some funding constraint and technical challenge. And thank you for your listening.